Hi everyone! For today's video, we're going to talk about static equilibrium. What is static equilibrium? Static equilibrium is where an object isn't moving because the various influences on that object are in balance. A rigid body is just an object that has a particular shape that doesn't change. So static equilibrium of a rigid body is the state where a solid object isn't moving because its influences are balanced. It is a static equilibrium if the net force is zero and the acceleration is 0 ms. How do we determine if it is a static equilibrium? There are two conditions that have to be met for this to be the case. The object must be in both transitional and rotational equilibrium. Transitional equilibrium is where an object moves left or right, forward or back, up or down. It is a movement of the whole object in a particular direction. The object is said to be in transitional equilibrium if the forces are balanced in all directions. Example is a parked car. It stays where it is because the forces on it are balanced. The downward force of gravity is balanced by the ground pushing back up on the car. Another example is a book resting on a table. It is a transitional equilibrium because the downward gravitational force on the book is exactly balanced by the upward normal force from the table. It has no force acting up on any direction. Rotational equilibrium. Rotational motion is where an object stays in position but twists around a pivot point, a state in which the sum of all torques acting on an object is zero, resulting in no angular acceleration. The object is either not rotating at all or is rotating in a constant angular velocity. This is the formula of a rotational motion with a constant angular acceleration. Example of a rotational equilibrium is a balanced seesaw. Imagine a seesaw with two children sitting on opposite ends. One child is heavier than the other but it is sitting closer to the center. The lighter child sits farther away from the pivot. The torques created by each child balance out, meaning the seesaw doesn't tilt or rotate, it stays level. Another example is a door held open at a 90-degree angle. When a person pushes on the edge, they create a torque that tends to rotate the door around its hinges. The door weight generates a counteracting torque downward through its center of gravity. If these torques are equal, the door remains stationary, demonstrating a state of rotational equilibrium. What have you analyzed in this picture? The picture is in a state of equilibrium, and thus all the forces acting up upon the picture must be balanced. That is, all horizontal components must add to 0 Newton and all vertical components must add to 0 Newton. The leftward pull of cable A must balance the right pull of cable B. The sum of the upward pull of cable A and the cable B must balance the weight of the sign. Example of a static equilibrium. The weight of the statue pulls it down, while the pedestal pushes up with an equal force. Because these forces balance each other, the statue remains still and does not move or tip over. There are no forces causing it to rotate, so it stays stable. Angular momentum. Angular momentum is like a momentum for things that spin or rotate. It shows how much rotational motion an object has. Formula of angular momentum is momentum of inertia times angular velocity. Example, a spinning ice skater pulls in their arms to spin faster because they're changing their angular momentum. How torque affects angular momentum? Torque is a force that makes something rotate or twist. When you apply torque, you change the angular momentum. Example, if you push on the edge of a spinning top, you'll make it spin faster or slower, depending on the direction of your push. That's all guys! I hope you learned something and thank you for watching!